Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on trigonometry degree level chapter Summation of Trigonometrical Series lecture number 9, in which I will solve some more problems by method of difference. Now we solved a problem. Problem is find sum to n terms of the series tan inverse x plus tan inverse x by 1 plus 1 into 2 x square plus tan inverse x by 1 plus 2 into 3 x square plus dot. Here we see that in the second term, here 2 multiply 2 minus 1 means 1. In the third term, 3 multiply 3 minus 1, that is 2. 2 multiply 3. So, we may find the nth term as here n into n minus 1. Let Tn equal to nth term. Therefore, Tn equal to tan inverse x by 1 plus here n minus 1 x square. This is equal to tan inverse n x minus n minus 1 x. This is equal to x by 1 plus n minus 1 x multiply n x. This is n into n minus 1 x square. If we put n equal to 1, we get 1x minus 0 into x, that is x, and here we get 1 minus 1 0, in denominator 1 only. This is equal to tan inverse nx minus tan inverse n minus 1x. This is number 1. Putting n equal to 1, 2, 3, dot, n, we get here T1 equal to tan inverse 1x minus tan inverse 1 minus 1x. This is equal to tan inverse x minus tan inverse 0. Tan inverse 0 is 0. T2 equal to tan inverse is 2x minus tan inverse x, 2 minus 1x, tan inverse x. T3 equal to tan inverse 3x minus tan inverse 2x, and dot. Tn equal to tan inverse nx minus tan inverse n minus 1x. Since tan inverse 0 equal to 0, this is 0. So T1 equal to tan inverse x. This is tan inverse x. Adding we get T1 plus T2 plus T3 plus dot 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 plus Tn equal to, here we see that we may cancel tan inverse x, tan inverse x, here positive, here negative, tan inverse 2x positive, tan inverse 2x negative. So this diagonal cancel, only remains tan inverse nx minus tan inverse 0 equal to tan inverse nx minus 0. This is equal to tan inverse nx. This is the answer. Now we solve the next problem. Next problem is find sum to n terms. Tan inverse 1 by 1 plus 1 plus 1 square plus tan inverse 1 by 1 plus 2 square plus tan inverse 1 by 1 plus 3 square plus dot 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 dot. Let Tn equal to nth term. Therefore, Tn equal to tan inverse 1 by, here in the first term 1 plus 1 square, in the second term 1 plus 2 square, in the third term 1 plus 3 square, in nth term 1 plus n square, 1 plus n square, and this is equal to tan inverse 1 by 1 plus n common 1 plus n. We may write this tan inverse n plus 1 minus n by 1 plus n plus 1 into n. We may write this tan inverse n plus 1 minus tan inverse n. Let this is number 1. Putting n equal to 1, 2, 3 dot 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 n, we get T1 equal to tan inverse n equal to 1, 1 plus 1 2, tan inverse 2 minus tan inverse n equal to 1. T2 equal to tan inverse 3 minus tan inverse 2. T3 equal to tan inverse 4 minus tan inverse 3 dot 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 dot. Tn equal to tan inverse n plus 1 minus tan inverse n. Adding these, we get T1 plus T2 plus T3 plus dot 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 plus Tn equal to, we add, this is positive sign tan inverse 2 and tan inverse 2 negative sign. Cancel tan inverse 3 positive sign, tan inverse 3 negative sign. Cancel, this diagonal cancel. So remains only tan inverse n plus 1 minus tan inverse 1. We may write this tan inverse n plus 1 minus, this is pi by 4. This is the required answer. Now we solve the next problem. Next problem is find sum to n terms. Tan inverse 1 by 3 plus 3 multiply 1 plus 1 square plus tan inverse 1 by 3 plus 3 multiply 2 plus 2 square plus tan inverse 1 by 3 plus 3 multiply 3 plus 3 square plus dot plus tan inverse 1 by 3 plus 3 multiply n plus n square. Now we solve this. Given that nth term equal to tan inverse 1 by 3 plus 3 multiply n plus n square. This is equal to Tn. Let therefore Tn equal to tan inverse 1 by, here we see that this may be written as 1 plus n plus 1 multiply n plus 2. Here if we calculate this is n square plus 2n plus 1n 3n plus here 2 1 multiply 2 plus 1 3. So we have adjusted this and we may write this tan inverse n plus 2 minus n plus 1 by 1 plus n plus 2 multiply n plus 1, and this is equal to tan inverse n plus 2 minus tan inverse n plus 1. Let this is number 1. Putting n equal to 1, 2, 3 n, we get T1 equal to tan inverse. Putting n equal to 1, 1 plus 2, 3, tan inverse 3 minus here 1 plus 1, 2, tan inverse 2. T2 equal to tan inverse n equal to 2, 2 plus 2, 4 minus tan inverse 3. T3 equal to tan inverse 5 minus tan inverse 4 Tn equal to tan inverse n plus 2 minus tan inverse n plus 1. Adding these, we get T1 plus T2 plus T3 plus plus Tn equal to, here tan inverse 3 positive, tan inverse 3 negative. So this cancel, tan inverse 4 positive, tan inverse 4 negative cancel. So this diagonal cancel, only remains tan inverse n plus 2 minus tan inverse 2. We may write this as tan inverse n plus 2 minus 2 by 1 plus n plus 2 multiply 2. So this will be equal to tan inverse, here only remains n, here 1 plus 2n plus 4, and this will be equal to tan inverse n by 2n plus 5, and this is the required answer. Now we solve the next problem. Next problem is find sum to n terms. Tan inverse 1 by 3 plus tan inverse 2 by 9 plus tan inverse 4 by 33 plus tan inverse 2 to the power n minus 1 by 1 plus 2 to the power 2n minus 1. If we put n equal to 1, then 1 minus 1, 0, 2 to the power 0 is 1 here, and here n equal to 1 means 2 minus 1. So 2 to the power 1 is 2, 2 plus 1 equal to 3. So this will be the nth term. Nth term equal to tan inverse 2 to the power n minus 1 by 1 plus 2 to the power 2n minus 1 equal to Tn. Let this is number 1. Since 2 to the power n minus 2 to the power n minus 1 equal to, we take common 2 to the power n minus 1, remains here 2 and remains here 1. So this is equal to 2 to the power n minus 1 multiply 1 equal to 2 to the power n minus 1. So in place of 2 to the power n minus 1, we may write this left side. This is number 2. And 1 plus 2 to the power 2n minus 1. We may write this 1 plus 2 to the power n plus n minus 1. And we may write this 1 plus 2 to the power n multiply 2 to the power n minus 1. This is number 3. Using 2 and 3 in 1, we get Tn equal to tan inverse 2 to the power n minus 2 to the power n minus 1 by 1 plus 2 to the power n multiply 2 to the power n minus 1. And this will be equal to tan inverse 2 to the power n minus tan inverse 2 to the power n minus 1. Let this is number 4. Putting n equal to 1, 2, 3, n, we get T1 equal to tan inverse, in place of n we write 1, tan inverse 2 to the power 1 minus tan inverse 2 to the power 1 minus 1, 0 means tan inverse 1. T2 equal to tan inverse, here in place of n we write 2, tan inverse 2 to the power 2 minus tan inverse 2 minus 1, 1, 2 to the power 1. T3 equal to tan inverse 2 cube minus tan inverse 2 square and Tn equal to tan inverse 2 to the power n minus tan inverse 2 to the power n minus 1. Adding these, we get here tan inverse 2 positive, here tan inverse 2 negative. Cancel. This is positive, tan inverse 2 square, tan inverse 2 square negative. So this diagonal cancel. So this diagonal will be cancelled. So remains T1 plus T2 plus T3 plus plus Tn equal to, here tan inverse 2 to the power n minus tan inverse 1. This equal to tan inverse 2 to the power n minus tan inverse 1 means pi by 4. So this is the required answer. Now we solve the next problem. Next problem is find sum to n terms. Tan inverse 1 by 2 multiply 1 square plus tan inverse 1 by 2 multiply 2 square plus tan inverse 1 by 2 multiply 3 square plus dot 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 dot. Here we see that in the first term here 1, here 2, here 3. So RS term will be equal to tan inverse 1 by 2 multiply r square. We may write this tan inverse 2 by 2 multiply 2 r square equal to tan inverse 2 by 4 r square. Here we add 1, we subtract 1. So this will be tan inverse 2 by 1 plus 2r square minus 1 square. This will be equal to tan inverse 2 by 1 plus a square minus b square is a plus b, a minus b. We may write this tan inverse 2r plus 1 minus 2r minus 1. Here 2r and 2r cancel, plus 1 minus minus 1 plus 1 2. So numerator will be this and 1 plus 2r plus 1 2r minus 1. And this will be equal to tan inverse 2r plus 1 minus tan inverse 2r minus 1. Let this is number 1. Let this is equal to TR. Putting r equal to 1, 2, 3 dot 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 n, we get T1 equal to tan inverse r equal to 1, 2 plus 1, 2 multiply 1 plus 1 minus tan inverse 2 multiply 1 minus 1. And this will be equal to tan inverse 3 minus tan inverse 1. T2 equal to tan inverse, in place of R2, 2 multiplied with 2, 4 plus 1, 5 minus, here R equal to 2, 2 multiplied to 4 minus 1, 3, tan inverse 3. T3 equal to tan inverse R equal to 3, 3 multiply 2, 6 plus 1, tan inverse 7, tan inverse 5, and dot 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 dot. Tn equal to tan inverse 2n plus 1 minus tan inverse 2n minus 1. Adding these, we get T1 plus T2 plus T3 plus dot 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 plus Tn equal to, here tan inverse 3 positive, tan inverse 3 negative, cancel, tan inverse 5 positive, tan inverse 5 negative, cancel. So this diagonal will be cancelled, only remains tan inverse 2n plus 1 minus tan inverse 1. We may write this equal to tan inverse 2n plus 1 minus 1 by 1 plus 2n plus 1 multiply 1. This equal to tan inverse 2n plus 1 minus 1 by 1 plus 2n plus 1. This is equal to tan inverse plus 1 minus 1 cancel 2n. Here 2n plus 2. This is equal to tan inverse 2n. Here we take common 2n plus 1. And this is equal to tan inverse 2 cancel n by n plus 1. This is the required answer. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button, and if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.